Hi and welcome back to our educators. So for today I'm going to continue with part 4 for video chapter 4, which is periodic table, and we are going to discuss in detail for elements in group 17. Okay, so elements in group 17 consist of fluorine, chlorine, bromine, iodine, and then you have astatine, and also what is the another one? By time you must be able to tell the names properly, astatine and also tennessine lah. Okay, but remember that your application would be on chlorine, bromine and iodine. You will learn the chemical properties of these three things only. So why we are not learning the chemical properties of fluorine, astatine and tennessine would be stated in this video in the end of the video, and we would discuss about the reactivity. How does reactivity of elements in this group works? Okay, how does the concept of reactivity works? Okay, so basically I already wrote the notes earlier before this video, so I'm just going to explain the notes. So what I want you to do is please open your textbook page number 95. Okay, so we are going to discuss about the whole content in this page, the changes and also the physical and chemical properties of other elements. So this video going to discuss everything about that. So I hope you enjoy the video and make sure you do notes. Okay, and for those who wants my note, I would give you once I'm done with the total notes for this whole chapter. I'm going to do the notes, and maybe I'm going to sell the notes in a Shopee or in any websites as a soft copy or hard copy. Okay, depends on the time lah. Alright, okay. So as for now, okay, let's understand first the reactivity. Okay, first thing first, group 17. Okay, so whenever I talk about group 17, what should come in your mind first? For sure, if group 17 means they have how many valence electron? 7 valence electron. So to become balanced, they should donate the 7 or they should accept 1 to become 8. Okay, yes, the correct answer is they should accept one electron lah to become 8 or 18. So something like that lah. Okay, that one we will see later. Okay, so our study basically would be focusing on chlorine, bromine and iodine as what I said to you, and then we come out with the proton number first. Chlorine, the proton number is 17. The moment you have the proton number, please do the electron arrangement. Okay, so chlorine, they have 17 protons, meaning that if it's an atom, they have 17 protons and 17 electrons. So the electron arrangement should be 2, 8 and 7. Yes, correct. And then for bromine, they have 35, meaning that they have 35 protons and 35 electrons. So when the proton number exceeds 20, you learn in chapter 2, when the proton number is more than 20, your third shell can occupy maximum 18 electrons. But it is not same when your proton number is below 20. If below 20, your third shell can maximum have 8 only. Okay, so you can see this one need 1, this one also need another one, this one also need another one. So for sure they must fulfill the final shell to become balanced. So they need one electron. Okay, so what we must do after this? Okay, so actually to make it more clear, right, we will study, okay, among these three, who will accept the electron very fast, because they have different proton number. If the proton number is big, the atomic size is big. Why? Because, okay, let's do an example. Okay, let's draw chlorine. Okay, I draw below here lah. Okay, so this is the first circle. Okay, chlorine. Okay, 1, 2 and 3, and the atomic size is sorry, the electron arrangement is 2, 8 and 7. Correct? Okay, I draw first. Then next we try to draw for bromine. Okay, 35. Okay, let's draw for bromine. Okay, so I use a different color lah to show the difference. Okay, so this is bromine. Okay, so bromine in total they have 4 shells, 2, 8, 18 and also 7 in the final shell. Correct? Okay, so just draw long. Okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This shell have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then you know we have another 2, right? Okay, so the another 2 I just randomly place somewhere lah. Okay, so I just place it because lagi 2 tu dia kena berpasangan, right? So okay lah, I place somewhere here. Okay, this have 2. Okay, and then the final shell have 7, correct? Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see whose atomic size is bigger. I ask you. You can open your eyes and see betul-betul. Atomic size ini will be is bigger for bromine lah. Kenapa? Sebab you tengok, you can see by your eyes kan. Okay, this one kecil je, ni besar betul sebab they have a lot of electrons. So for sure lah the size is bigger, right? So the moment you say that they have more electrons, that one is the biggest. Okay, then itu you punya first thing that you must see. Okay, after that, when I want to test reactivity, I would compare in this way. Okay, wait, I bring this to bawah lah. Okay, I bring this to bawah sikit sebab easier. Okay, dapat screenshot je lah. Oh my god, kenapa dia slow? Okay, somewhere sini lah. Okay, just put it here first. Okay, so you see how I explain. Okay, the number of shells occupied with electron increases. So the first point to compare the reactivity. Okay, compare reactivity. Okay, tulis dulu atas. Okay, so the first point untuk compare reactivity adalah we will see the atomic size. Betul tak? So atomic size siapa punya besar? Bromine punya besar. So you must tell that one, the atomic size for bromine atom is bigger than chlorine atom. Full stop. Then second, the number of shells occupied with electron increases. For whom? For sure for bromine lah. Why? Because dia punya apa? Dia punya electron banyak. They have more electrons. When they have a lot of electrons, for sure they need more shells to occupy, to place all the electrons. Correct? So that one should be your second point. And then atomic radius. Okay, what is atomic radius? How to know your atomic radius? So to know your atomic radius, okay, you take your pen. Okay, this is your nucleus, correct? This circle is your nucleus. From this circle, you tarik until valence shell, the last shell, and then you do the same thing to this fellow also. Okay, now I ask you, you dah tarik macam ni kan? So atomic radius for whom is bigger? Chlorine ke bromine? For sure bromine lah yang besar. Sebab you can see, right? Yeah, atomic radius. This one they cross only one shell completely. Ni 1, 2, 3. Nampak tak? That one like memang you can see by your eyes lah. I don't know how to explain in detail. Okay, memang you can see by your eyes. The atomic radius for bromine is bigger. And then the valence shell. Okay, dah nama pun the atomic radius is bigger for this filler, right? Then you see the valence shell. The distance for your valence shell, the final shell from nucleus. Okay, for whom? Jauh, very far. For sure, bromine lah. And then we have the nuclear attraction force. So because bromine one is jauh, so the nuclear attraction force would be strong or weak? Weak lah. Sebab the more jauh you are, like let's say lah, okay, you are standing like 1 kilometer far away from me. So for me to pull you is very hard. But let's say lah, you stand just nearby to me, like 100 meters sahaja. Nak tarik you very easy. Okay, that's the concept for nuclear attraction force also. And then more difficult to attract electrons to fill the valence shell. So this is the guideline. So I will show you if in your exam how they want you to answer. Okay, let's see. Okay. So you must compare the atomic size, right? Like what I say. So you must say the atomic size. You can say the bigger one or smaller one, up to you. The atomic size for bromine atom is bigger, or you can say larger than chlorine atom. When you are doing reactivity comparison, make sure you show the comparison in your sentence with the usage of than or more than something like that lah. Okay, you can compare. Alright, so that's the purpose why we teach you this one. Okay, then chlorine atom. So betul, atomic size is bigger, and then the number of shells. So you say bromine atom is bigger, right? So the number of shells occupied with electron for whom is a lot. Okay, for sure the number of shells occupied with electrons is higher for bromine compared to chlorine. Why? Because you see bromine have how many shells? 1, 2, 3, 4. Chlorine 1, 2, 3 only. So siapa yang besar? For sure bromine lah. Okay, so you must write that. The number of shells occupied with electrons for bromine atom is higher or bigger lah, up to you lah, higher than chlorine atom. Okay, so you compare the number of shells. After that, atomic radius. So atomic radius siapa yang bigger, chlorine ke bromine? Come again. Yes, bromine. Kenapa? You can see by your eyes, right? How I do atomic radius. This is the way to do atomic radius. You cari a line from the nucleus until the valence shell. Then you see siapa punya yang besar. Siapa punya yang panjang. So for sure, the one that with more protons lah. So bromine, right? So you can say the atomic radius for bromine atom, normally for atomic radius we say larger lah, but bigger also acceptable lah, is bigger than chlorine atom. Remember when you start to compare with you start with bromine, make sure until the whole comparison pun you talk about bromine juga. Don't sekejap bromine then you sekejap you bawa chlorine ke depan. It's not a proper way. Make sure your answer is easy to understand. Alright, then chlorine atom. So once you are done with this comparison, then you see you must talk about the valence shell. So the valence shell for whom is further apart from nucleus? Chlorine or bromine? Obviously bromine lah. So you can say the valence shell for bromine atom is further apart. Okay, meaning that it's far. Okay, because the changes, the transfer or receiving or donating of electrons will start with valence shell. Okay, they won't simply masuk sel-sel yang dekat dengan nucleus. They will always start with the valence shell and valence electrons lah. So the valence shell for bromine atom is further away from nucleus compared to valence shell of chlorine atom from nucleus. So this is the proper way. Make sure kalau you give comparison, the comparison is very clear and very direct. Okay, so after you compare the valence shell, remember you must compare the nuclear attraction force. So the nuclear attraction force, right, weaker. So whose one is weaker? Chlorine ke bromine? Come on, you see very far. The nucleus dengan valence shell very far for bromine. Chlorine dekat sikit. So you talk about bromine, right? So bromine one weak lah. Yes, correct. So you can say the nuclear attraction force towards the nuclear attraction force. Okay, you can tambah this one sikit. The nuclear attraction force from the protons in the nucleus towards, oh my god, okay, oops, 1 minute, towards electrons, or you can say valence electron, lagi better, okay, towards valence electrons in valence shell. You know that why I say you must say valence electron, because your transfer, your donation, whatever starts in valence shell and a valence electron. Okay, that's why we must mention that it's better to mention valence electron. This is the difference between A plus and A student, you know. If you mention valence electron, kira you are very detailed. So benda-benda macam tu sometimes you won't deduct marks. If let's say you say electrons only, sometimes if we feel not deduct, we will deduct because it's by fact it's wrong actually. Okay, in valence shell, chemical response from the protons and nucleus to the valence shell. For bromine atom is weaker than chlorine atom. Okay, so I hope you understand this one. I explained in a very clear manner, so make sure you understand lah. Then chlorine atom. Okay, so after that, so now the nuclear attraction force is weak for bromine. So you think they can easily attract electrons to fill the valence shell or cannot? For sure cannot lah. So you must say the bromine atom will be difficult to attract electrons. I mean, not to say electrons, like electron only, like, because we need one only to fill, right, the valence shell compared to chlorine atom. So this is the complete answer. Okay, how should you answer if this one become a essay question in your SPM? So this is the proper way lah. Okay, you must compare every single thing properly. So literally we have 6 points. So this is how you should compare. So I already gave you the guideline, and then I already give you the sample answer. So I hope you already copy. If let's say you didn't copy, just go back. Go back for the video, pause the video and copy all the answers. Okay, and I hope it can be a reference for you lah untuk jawab reactivity questions. So now quickly, from what you learn in this example, I ask you, siapa would be feel very hard to fulfill the valence shell from these three? So for sure iodine lah, because why? Iodine atomic size is big. So terus jam, you see the atomic radius, so the nucleus and valence shell is very far. So you think easy to attract electron or hard? Hard. So when it's hard, its reactivity is increase or decrease. Remember, this group, they must receive electron. If they receive electron easier, they are very reactive. If it's very hard that for them to receive electron, they are not reactive. So for sure this one not reactive lah. Okay, this one very reactive, this one second, and this one third. So correct lah, they say reactivity decrease is correct. Why? That's the reason. Okay, the 6th sentence that I give to you. So I already put a reminder here. Note, group 17 elements reactivity depends on how easy for its atoms to attract or receive electrons from another atom. If easier or small size, very reactive. So from all these three, who is very small? Chlorine. So who can attract electrons easily? Chlorine. Why? Because the nuclear attraction force is higher or stronger. Okay, so that should be the reason. Nuclear attraction force mostly strong lah. Okay, you will say strong and weak. Okay, it's not higher. So I hope you understand that one. And we have one final part, properties. Okay, so this one are the properties, the chemical properties and physical properties of other elements in group 17. Like just now in the starting of the video, I tell to you, right, why we didn't study about fluorine gas and also astatine, correct? Do I mention about it in the earlier part of the video or no? If siapa watch dari depan, they know lah. Okay, I do mention about them. So why? Okay, generally fluorine is a gas just like chlorine, but fluorine is very reactive. Okay, they are very reactive. So light yellow gas is the physical properties. You can see it's a light yellow gas, but about the poisonous, very reactive, corrosive, and it can cause a strong explosion if combined with hydrogen gas or their chemical properties. So you can take note this one. That's why we didn't learn, because our atmosphere itself have hydrogen gas. So when you test this filler with the lab or something like that, can cause strong explosion. So the next day I kena jumpa you di rumah mayat lah if you do that. So that's why we won't galakkan to do any experiments about fluorine gas lah for SPM level. Alright, and then finally properties for astatine. Astatine is a rare radioactive element which is not chemically stable. So that's why we didn't study about astatine also. While tennessine, the final one, last one, where ni TS ini kan, why we didn't study about them? Because as far as I concerned, they say it's a newly discovered halogen. So that's why we didn't study about them lah. Okay, so that's all for this video. We already discussed about the reactivity and also the physical and chemical properties for other elements in group 17. So I hope you understand my explanation and it's clear for you, especially this part. Okay, this explanation about reactivity. Maybe you can do a homework, a question. You can compare the reactivity between bromine and also iodine, then you can tell who is very reactive. Okay, so just now we made a conclusion here. The one that very reactive is chlorine. Okay, not bromine. Okay, so I hope it's clear for you. You can give a try between bromine and iodine. Then you can say to me lah whether you understand or no. For those yang tak faham, please play back the video and see. Okay, I would like to remind again, see the atomic size and then see the atomic radius and then see the distance of valence shell and nucleus. See that one first. Okay, valence shell and nucleus. Susah, if very hard, I mean very far, so it's very hard to attract electrons. So less reactive. That's how you must understand lah. Every group, the concept of reactivity is quite different lah, but by somehow you must understand first whether they need electron or they must donate electron. If they must get electron, that one different concept. If they must donate electron, that one different concept. Also you must understand all those things lah. Okay, so literally group 17 is totally different with your group 1. Okay, your group 1, they need to donate the one electron. Your group 17, they need 1 electron. They must accept 1 electron from other sources, from other elements. Okay, that's the difference lah between both of this group. So it's okay, tak payah cakap panjang because the video already so long. So you can give a try for test yourself 4.5 first, and then you can tell me lah, okay, whether you understand or no, or you need any further explanation. You can comment down in the comment box so I can help you. So after this, I'm going to record for the physical properties of these 3 elements and then the chemical properties. So I will try my level best to finish up all the videos for group 17 by end of this week. Okay, so you can use it for your study purpose. Okay, that's all from me. Thank you and bye.